Everyone. So thank you first of all for coming to this talk. I'm going to be talking to you about a topic that I've been hearing a lot about today at the conference, which is artificial intelligence. And a little bit about what does it mean today and where are we heading towards and what are some of the interesting trends and things that I've personally seen. So a little bit about myself. I'm a developer by background, started programming, I was about 12 years old. Massive computer geek in general, and co-founded a company about 18 months ago called Sourced. And I'll talk to you a little bit in the beginning about what we do at Sourced, but most of this talk will really be focused around artificial intelligence and deep learning and some of the less popular terms as well. So this is a lot of text. You don't have to read it, but the reality is I couldn't condense this into anything smaller. So what we do at Sourced we believe that software engineers are some of the most creative professionals that exist in the world. They are similar to artists, similar to writers. And the reason I believe that if you're a software engineer, you are that creative and so similar to a painter is because you work with a raw material. Right? If I'm a developer, I work with a programming language. Most programming languages today have 60 tokens, of which 40 are words. Right? Very, very small. If I'm an English language writer, I have the 300,000 words in the dictionary. And if I'm a painter, I have my colors and paints. In reality, it is not that different if you're a software developer who is creating a piece of code, or if you're a painter or an artist or a writer creating a piece of art or something people can consume. Because at the end of the day, it's up to your own ability and your own creativity to be able to create something. Right? You could have been creating Kubernetes that we saw earlier, or the operating system on a Mac. So at Sourced, we believe that because software developers are so important in society, and the reason I mention that is today technology is everywhere, right? Everybody here pretty much believes this, but there's still only about 20 million professional software engineers in the world. That is a very, very small number considering technology is impacting billions of people globally. And at the same time, I personally know a lot of software engineers who are mastering their craft, who are incredibly creative, have a lot of ability, but they're working on a team or a project where they're just not happy. Right? They're working in a code base where they're not able to actually express what they do. So what we do at Sourced is we work in an area called deep learning. Right? In the press, you often hear it as referenced as artificial intelligence. And using deep learning and using neural networks, which I'll talk a little bit about today, to build an understanding of source code. One about the style of source code, the semantics of source code, and I'll talk a little bit more towards the end. But that's essentially what we do. This is why we have a little bit of insights into this space. I've been working with this on several years, and both at the code level and more on the higher level stuff. But today I won't be talking too much about Sourced. I'll be talking a little bit about what I call the democratization of AI. And more so than that, that title doesn't really hold true always. So when we talk about artificial intelligence, I think it's important that people separate it in kind of the three categories that have been given by some of the philosophers into space and some of the people who think more about AI on a high level. You have artificial narrow intelligence that essentially is, I am using technology, particularly technology that uses neural networks or similar types of technologies, to be able to solve a very narrow problem. A very narrow problem is Siri able to understand your voice, or it is Google being able to understand that there's a cat in your photo. And then we have kind of general intelligence, the point that some people believe we'll get to, where machines and AI is at the same level as a human, that any task that we're able to complete and any reasoning that we can do, a machine is able to do. In my opinion, we're quite far away from this still. Right? And when you see things like AlphaGo, where the DeepMind technology that was beating Lee Sedol in one of the most amazing battles of Go, that you're still talking about narrow intelligence. Right? It is a system that's able to solve one specific problem very well. And then we have this thing called ASI, artificial superintelligence. This is essentially where you hear a lot of people talk about that, are we all screwed? Is there going to be some technology that takes over the world and we as humans become irrelevant? I'm no one to give an opinion on this, and I'm also no one to tell you if we'll ever get there. But what we've seen in the last few years is that in ANI, artificial narrow intelligence, we're making incredible strides, and we're seeing this technology become part of every single thing we touch every day. So when we talk about AI today, we talk about neural networks. I won't go into too much depth, but essentially neural networks is a technology, an approach that was created in the 80s and first thought about then, that mimics the way computers can learn from data, similar and very loosely similar, based on how neurons fire in our brain. But essentially the main difference is that till date we've been programming with statements. If this happens, then do X, and else do Y, etc. With neural networks, we don't try to build in actual logic. We try to learn from data. So I'll be talking a little bit more about that today, but if anybody's interested, come up to me after and we can have lots of geeky talks about this. So one of the things that for me personally was very apparent is that getting into the field of neural networks and deep learning was relatively easy. I came from a background where I didn't get a PhD in this area. I didn't have a master's degree in this. But I essentially was a software engineer who was interested in this and started reading research papers and started looking at code on GitHub. And this is a little bit today what I want to talk about is that when you talk about democratization of AI, you're seeing that this is one of the technologies similar to the internet that a lot of people have access to. And the cutting edge research today is as easily accessible to you, to the top guys in Google. So just to run you through a little bit of some of the tools and things that we're seeing that are enabling this. So there's a website called archive.org. And Archive is essentially what you call a preprint server. A few years ago, I didn't know what a preprint server was, but essentially it is where academics or anybody who writes research papers can upload their work for others to review and see it before it goes off to an academic journal where it gets reviewed and decided if it gets included. Why is this so incredibly important in the area of deep learning and neural networks? It's so important because today in the community there's become this culture that if you have some interesting research, you put it here. And if you're first here, you're the first one who's thought of it. So there's a huge competition in the community of engineers and researchers who are looking at neural nets and looking at deep learning. They're starting to put their work here. And right now, it's gone from several years ago of a handful of research papers coming on every week to now hundreds and hundreds of research papers coming on every single week. To be honest, my job is reading a lot of them and it becomes quite difficult these days because there's a massive amount of content coming on. But the most interesting thing is if some interesting research is happening in Google or it's happening in a small startup in China, all of a sudden you can read about it here almost in real time. Where before in a lot of areas of science and less so in computer science, you had to wait till something got accepted into an academic publication, maybe 6 or 9 months later after it was originally created. And we were building on top of research at this kind of relatively slow curve. That is not the case anymore, particularly in deep learning. And this has become very interesting because all of a sudden, somebody like myself who doesn't work at Google or doesn't have a PhD in this area could follow the research and start learning more and more about this. Then we have the fact of, what do you actually need to run neural networks, right? And over the last 20 years, the growth of open source has been incredibly impressive. In our company, we index and download and analyze every single public code on the web. And if we go back a little bit, in 2008, there was about 500,000 code projects, the Linux kernel, Firefox, all of these kind of things that were public open source projects. Today, there's over 22 million code bases that are publicly hosted on the web. These are some of the libraries that are specific to deep learning. And one of the things you see here, that by far the most popular one is TensorFlow. TensorFlow was one that was released by Google. And in my opinion, it was a genius move by Google because what it actually meant is that they understood it wasn't about the library, it wasn't about the technology that allowed you to do neural networks. It was about if you give that technology to everyone else, you increase the rate of research, you make it more equal and accessible for people to start working with AI and with deep learning. And more so than that, if everybody is using the same code base that you're using inside your company, outside your company, it becomes incredibly easy over time to hire people, right? I think there was some of the strategic thinking behind it at Google. Could be wrong here. Then GitHub, right? GitHub today has become indistinguishable with being a developer. There's over 8 million developers who have publicly put code online on GitHub. And today, when a research paper comes out on Archive, either the authors themselves include the code right? You can replicate the research. And I think one of the most important things in research in general is reproducibility, right? The ability to look at somebody's results, run it yourself, and actually see if they're real and if they're true. And this allows you not just to be able to come across a new concept and read about it and think about it. It allows you, in most cases, straight away to run the code and modify it to your own things. Right? I cannot stress the importance of this. And at the same time, when you look at companies that are not yet releasing their code, so Google DeepMind has some very interesting projects that come out in Nature and in Research, etc. And what you see that within weeks of their research coming out, there are some developers around the world who've taken those ideas, implemented them in TensorFlow or in another library, and made the code publicly available. So you yourself can get access to it. Twitter. A lot of people still don't get Twitter. It took me a long time as well. But the reality is, in the deep learning community, all of the interesting discussions are happening on Twitter. When you have hundreds of research papers coming out every week, you don't have time to filter through them. Right? You need people to tell you, have a look at this, let's discuss this. And funny enough, the medium for that really has become Twitter. So this combination of all of these kind of things, right? Archive, GitHub, Twitter, open source libraries, has created this open ecosystem where anybody can come in, learn about this area, improve and contribute, right? We're a small company of 30 people. We started a year and a half ago, and today we're contributing back to the core of TensorFlow. We couldn't have done that, neither if it wasn't an open source project, but also if the research wasn't out there for us to build on. It really gives you a quick kind of arch and curve that you can work on. Then there's a few more trends, and I think that's probably the more interesting part of the talk. Today, if you're training neural networks, you're using graphic processing units, you're using GPUs, right? These are the same cards that were running the graphics on your computers, that are running the graphics inside the PlayStation. This is a graph that ends at 2011. I couldn't find one that goes on to 2016, very beautiful. But the most interesting thing is that if you look at gigaflops is the amount of mathematical operations, floating point operations you can do a second. Graphics cards are particularly good at this, and behind neural networks is a lot of matrix multiplication, a lot of math. That today, these cards are able to process this data so fast that we just weren't able to do. And the reality is, the CPU in your computer doesn't matter anymore for neural networks. When you're training neural networks today, you're no longer even talking about gigaflops, you're talking about teraflops, and you're running it on graphics processing units. And I've been saying this for about 2 years. Like, the one company that really is amazingly positioned for this is NVIDIA. And if anybody recently saw their earnings report, they went way beyond what people had expected from a company that was traditionally just making cards for graphics. Today, if you're working in deep learning, you care about graphics cards. And then there's data, right? And the reason it doesn't matter that the research is open and that the libraries are open and that the computing power is becoming more available to everyone is that the real value is in the data, right? Google holds more data about people, about the web than almost any other company. So does Facebook, so does Amazon, so does Apple. So in my opinion, they genuinely don't care that the research is open, that other people can copy and improve on it, because the real value is in the data you hold, right? Because at the end of the day, the more data you have and the more clean it is and the better it's structured, the more valuable using deep learning and neural networks are. In reality, they're kind of useless if you don't have access to a lot of data. So everybody is essentially leveraging the fact that in the world there's so much innovation, there's so much research coming out, things are moving so fast, but the real people who are benefiting are the ones who have data, right? Either proprietary data or access to open data. But this is the interesting part, right? That we're starting to get into a world where, even though there's all of this democratization of technology and of artificial intelligence, the companies that really are going to be the ones that make decisions are the ones that have data. And getting access to proprietary data at the scale that Google has or Facebook has isn't possible unless you're a company at that scale. And this is where this democratization of AI starts falling apart a little bit, right? My title is kind of bullshit, because at the end of the day, it is not just about the technology anymore. It really becomes about the data. So we have this weird world where everybody has access to the research, but the real value is actually in who has access to the data. And big companies are smart about that, right? They protect it. They don't give access to everyone for that. And I think this is one of the things we're going to have to struggle with in the next few years, because as we see these technologies improving, the power of them does centralize at some very large companies. It is not like the internet where it didn't, right? And then, but let's go back a little bit to computational power, right? The size of data is increasing. We've all seen this. We look back at the sizes of our USB drives, 10 years ago, or the floppy disks. We see in our own companies how much data we store. At Sourced, we store in the petabytes of data. Several years ago, that was unimaginable as a small tech startup dealing with petabytes of data, right? Thousands of terabytes. But as the data grows, you also need more computational power, right? Before I could run things on CPUs, now I need GPUs. And the more data I have, I don't need one GPU anymore, but I need 100 GPUs. And the reality is, then we all go and say, okay, it makes a lot of sense to be in the cloud. But at the end of the day, when you have so much data you're processing, the cloud is no longer that inexpensive. Nothing is that inexpensive anymore because you need a lot of processing power. So again, we have this democratization that I have access to a lot of research, I can do a lot of things, but at the end of the day, unless I have a lot of money, it becomes hard to really be able to process data at scale. And it's true that the cost of computation always decreases, but the rate at which data sizes increases, in my opinion, is faster. And that becomes very challenging sometimes, right? This is again it democratizes, but as a smaller company, you might not have the opportunities, right? And then we see something else, and it's something that makes me very happy and very scared. And it's the fact that companies like Google and Microsoft are realizing that the GPUs that everyone else has access to, they're good. But if we just had very specialized chips, right, very specialized cards that are really designed for neural networks, and we have the access to the hardware, we have access to the brains, we can build this hardware and be a magnitude faster than everyone else before everyone else gets access to it. And this is what we see with, Google has TensorFlow processing units. They're essentially what we call ASIC chips, custom chips built for neural networks. And if you want access to those, you have to use Google Cloud. And in one hand, that's very good, right? Because you have the ability to scale up a lot of processing. On the other hand, it's not something that really is democratized yet. Microsoft is something similar that is not as fast but more reprogrammable, called FPGAs. And if anyone's interested in this stuff, we can talk geeky stuff about it after, right? And we see this as well. NVIDIA gladly is one of the companies that's moving more and more from a company of graphics to a company of deep learning. And they're one of the few companies like AMD and Intel that are positioned in the space to be able to, again, make this more democratic, right? Get this technology to other people. But what we're starting to see at deep learning at scale is something similar we see with Apple. Apple has several years advantages over everyone else because they built the hardware before everyone else does. So all of a sudden, where hardware at Google, in terms of neural nets and things, wasn't something you think about, now you see that this power is getting centralized at these large companies. What does that mean? I don't know. Right? When you see that the data is with certain types of companies, you see that the processing power is years ahead of certain types of companies, where are we left when we're new teams working with data or smaller startups? In most cases today, that means you need to have your specific niche. Right? Well, most areas in AI focus on computer vision, which is driverless cars and image recognition and natural language. In our case, we care about understanding source code, right? Which is something very specific that no one else really cares about. So we have our advantages there. But it becomes an interesting dynamic, right? And this is kind of what it comes down to me, is that if we really believe that AI is the next internet, right? It's the technology that's going to have the biggest impact in our society, we need to be a little bit worried about the same thing that's happened to the web. Right, the web started as this decentralized network. I remember, as a teenager, being behind my computer and being in, text-based games and, dialing into servers and all of this crazy stuff. And you would spend your time all over the web. But if I look at my web usage today, and I think it's for many more people even more apparent, I don't spend time on the internet anymore. I spend time on 10 different websites. Right? And I might read content that's hosted somewhere else, but the hubs are very centralized. And I think we're going to see the same thing happening in whatever we end up calling artificial intelligence. Right? And this is why it's important that organizations like OpenAI and other ones exist to try to make this more available and more democratic. But it is always this balance. If we want to push forward, if we want to be moving as society with AI faster than what we otherwise could, we need these big central powers. Right? So this is a little bit the big contradiction of today's talk. Right? There is this democratization. Everybody here with the right time and effort, and ability to mentally focus on it, can be looking at the same research that top deep learning researchers are doing at Google. But do you really have access to the same data, the same processing? Not really. Then on the other hand, we are, and I'm genuinely happy companies or like business units like Google Cloud exist and Amazon, because at least they're opening up platforms to other people. And it doesn't mean it's necessarily always the best or least expensive, but it gives you an ability to be able to work on a same skill that people can do. I think this is also the reason they let me talk here, even though I'm kind of talking about the big, bad, big companies. But this is, for me, the really interesting part. This is kind of what I spend most of my time thinking about these days. And one of the things you can do if you're running a tech company is you can try to be smart about. Let me rephrase it. We're a small company. I think many of you guys here are small tech companies, right? You're under 100 people or under 1,000 people. And because you're under 100 or 1,000 people, and you don't have these resources, you need to find things where you can really excel. In our case, we create some of the fastest open source libraries that work on graphics cards. So that even specifically on these graphic cards that are available, you're able to do things faster than you can do on Google's platform with TPUs or things like this. And you build yourself these little barriers of entry and a little bit of advantages that you can have. And by doing this more and more, you are again building on top the work of other people. Right? And this is the interesting part. You're always balancing between these two. So that's a little bit about, for me, what I consider democratization of AI, or maybe the fallacy of it. In our case, what we really, really care about as our company, and this is, if anybody afterwards would come talk to me about it, is the fact that developers and source code are so important today. It's no longer where 10 or 20 years ago there was this stigma of the guys in the IT basement who built the stuff that makes it run. Today we are in a society where if there's only 20 million software engineers building technology for 7 billion people, what is the world going to look like when we have 200 million software engineers, or 500 million? Because I have a lot of friends these days with young children, and almost all of them are kind of 3-4 years old and starting to go into primary schools. And what really amazed me is how many primary schools, at the age of 4, are starting to get children exposed to programming with apps like Scratch, and are starting to have courses in high schools that are starting to make this a priority. So if we really believe programming is becoming a second language to people, and that's what matters, then we need to accept that we're going from 20 million software engineers to maybe 500 million software engineers in society. And when you have there's hundreds and hundreds of millions of software engineers, you want them to be able to have democratic access to the best research, the best tools, so that it's not just the 20,000 guys at Facebook or at Google or at Amazon that are pushing things forward, but everybody is. And this is, for me, the reason our company exists. Right? We really want to be able to understand source code to put developers in the right teams and the right projects, so that they can help these kind of innovations happen. But these are just some of the thoughts I want to put out with you guys today. If there's any questions, let's shoot them out now. But first of all, thank you very much. Any questions? In our case? No, actually. So the question was, is the primary programming language, in our case, primarily Python, but I guess also in the general space of deep learning and things. In our case, we, funny enough, are a heavy Golang company, which is a programming language created by an engineer at Google about 6 years ago. So most of our data pipeline of what we built in Go. Then we, on the deep learning side, heavily use Python, but a lot of the things we work on are what's called CUDA programming. So we work programmed directly on GPUs, which is also some of the stuff we do with TensorFlow. Today, if you're working in deep learning, you're primarily working with Python. The Python API for deep learning libraries is most advanced. It's the easiest way to clean data, get it in there. We also are doing some things in Scala, because we run a large distributed platform on Spark. And for that, Scala works very well. I think today, when you're hiring good engineers, you need to be a language agnostic company. Right? Because the right developers choose the right language for the right problem. And for some things, Python makes a lot of sense for us. For other things, it just doesn't make sense. And then we have our personal biases. We find Go a very beautiful language, so we do a little bit too much in it. For anybody, since we deal with code, we have Git repositories. We analyze every Git repository in the world. We actually have the most popular open source library for Git, or second most popular in the world, written in Go, and we do a lot of stuff like this. Any more questions, guys? No? Well then, thank you very much.